Now let's start with the first case when object is kept at infinity. So remember, whenever an object is kept at infinity, the rays coming from the object will always be parallel to each other. So from infinity, the incident rays are always parallel to each other. Now, since the incident rays are parallel to each other, they can be parallel to principal axis or they can be inclined to principal axis. So we have got two cases when the object is kept at infinity, where you can say when incident rays which are parallel to each other are traveling parallel to principal axis, or the incident rays traveling inclined to principal axis. This is case B, right? So definitely, as I said, the incident rays which we will consider will be standard rays. Either they will be traveling parallel to principal axis or passing through optical center or passing through principal focus or appear to be passing through principal focus. So I hope you remember the three rules which we studied to draw the ray diagram for convex lens. So let's say these rays coming from infinity are parallel to each other. So definitely after refraction, so this is the first ray, this is the second ray. Since the ray is traveling parallel to the principal axis, after refraction it will pass through F2, right? And the second ray is also parallel to principal axis, so after refraction it will pass through F2. As I said, the position of image is a point where the rays after refraction meet at a point or appears to be meeting at a point. We can see that the refracted rays are passing through a point, so they will meet at F2. That means the image obtained is at F2. So if I talk about position of image, it is obtained at F2, right? If I talk about nature of image, tell me, the image is formed due to actual intersection, isn't it? The rays are actually intersecting at this point, so definitely the image will be real image. And I have already explained you that real image is always inverted with respect to object. Since here the image is a point image, so you can say it is highly diminished or diminished to a point. I would better say, since image is a point image, it is highly diminished. Okay. If I talk about second rays, okay, here the incident rays are parallel to each other because they are coming from infinity, but they are inclined to principal axis. Again, the incident rays I have considered, these are the standard rays. You can see the first ray is passing through optical center, then definitely it goes undeviated. So if I talk about this ray, the refracted ray will travel undeviated, right? And it will pass through the second focal plane. If I talk about the second ray which is passing through F1, then definitely after refraction will travel parallel to principal axis. If I draw this ray parallel to principal axis, I can clearly see that the rays are meeting at some point. Okay, here the rays are coming from infinity and the rays are meeting at a point. So this is a point where the image is formed. So if I talk about image, the image will be like this with a downward arrow, right? And where is the image formed? The image is formed on the second focal plane. If you remember the definition of second focal plane, it is a plane where the rays traveling parallel to each other but inclined to principal axis after refraction through lens meet at a point, right? So we can say if the parallel rays are traveling inclined to principal axis, after refraction they are meeting at a point. If you are considering a third ray, you can consider a third ray which are parallel to these incident rays, and after refraction definitely by definition it will pass through this point. So we can say the image is formed on the second focal plane. I can say at F2 or on second focal plane. So you have to be very careful in constructing all these ray diagrams, right? So as I said, when the object is kept at infinity, the image is either formed at F2 or second focal plane. Since this image is also formed due to actual intersection, So it is real, and you can see the image is found below the principal axis with an arrow downward. So definitely it's an inverted image. I can name it as A dash, B dash, and we can say that since the rays is coming from the infinity, the object must be very big in size and image is very small, so it is highly diminished. If I talk about applications of this case, you can see that we must have used a convex lens coming from the rays coming from the suns. We use the convex lens to converge the rays coming from the sun, and using that ray, okay,